Welcome, geniuses. I'm Genie, your best buddy for A-levels. In this channel, we'll bring you to explore the secret formula behind success.
Hi, this lesson we will discuss the permutations of R objects from N objects. The number of different permutations of R objects which can be made from N distinct objects is given by NPR, where N is an integer, N is greater than R, which is also an integer. When you use NPR to find the number of ways, the order of arrangement is important. So you will see the questions use the keywords like permutation and arrangement. Let's have a look of example 1. 8 runners are hoping to take part in a race, but the track has only 6 lanes. In how many ways can 6 of the 8 runners be assigned to lanes? That means we are talking about arrangement. Hence, the number of arrangements is given by 8p6. Now use your scientific calculator, press 8, followed by shift, and look for the multiplication sign button, press it, you will see capital P appears, right? Followed by 6 and press equal. Then you will see the answer calculated, which is 20160. So that means we select 6 out of 8 runners and then we arrange them to these lanes. And the number of ways we have is this. All right. So throughout the years of past year questions, they like to ask about restrictions. All right. And the common restrictions they like to ask will be like A, some people stand together, or some objects must be next to each other, or some people are separated from each other, or some objects are not next to each other. All right. Or another restrictions will be like this B, where it do not have all next to each other. Okay, we will look at some exam questions to discuss these restrictions. This is the questions from May, June 2010 and variant 6.3. 3 identical cans of cola, 2 identical cans of green tea, and 2 identical cans of orange juice. So the identical then are arranged in a row. So the keyword, calculate the number of arrangement. The keyword again, if part 1, the first and last cans in the row are the same type of drink. So this is the restrictions. So as we have 3 different types of drinks, we will consider the number of arrangement in different cases, like this. So we have case 1, and there are 7 cans of drinks. So first case, we put 2 cans of cola at the first and last. And case 2, we will put the green tea at the first and last. Then you can tell that the case 3 will be the orange at the first and last. Now, to find out the number of arrangement we have for case 1, we still have 1 can of cola and 2 green tea and 2 orange, right? Means we have 5 objects to be arranged in the middle. But don't forget, of these 5 objects, 2 green tea are identical. So we divide 2 factorial way is to get rid of the repeated way caused by these 2 identical green teas. And at the same time, we also need to get rid of the repeated way caused by the 2 orange juice. All right, using calculator, we will find the number of ways to be 30. We do the similar calculation for case 2. As the 2 green teas are the first and the last can, so there are still 3 cola in the middle and 2 orange. Now we still have 5 factorial ways to arrange them, but due to 3 cans of cola are identical, we need to divide them out, and 2 orange are identical, divide out. And the number of ways is 10. Now we consider the case 3. So the 2 orange at the ends, that means 3 cola and 2 green tea, right? So you can tell that the number of arrangement will be the same as case 2. It's going to be 10. So when we consider the number of arrangements in different cases, what do you do is to sum them up. All right. So we are looking for the total different arrangement, total number of ways. We sum up the number of ways found in case 1 and 2 and the case 3. So total, there are 50 different arrangements for the part 1. All right. Now we move on to part 2. The 3 cans of cola are all next to each other. Okay, this is the restrictions. And the 2 cans of green tea are not next to each other. So this is the second restrictions. So in order to consider these restrictions, we will write down like this. The 3 cans of cola are next to each other. So we put 3 cans of cola and we circle it as we discussed in the previous lessons. For the 2 cans of green tea are not next to each other. So I will put it as the side and we will consider them later. And we still have 2 orange. All right. So now we count 1, 2, 3. So effectively, there are 3 objects to be arranged. Hence, 3 factorial ways. And the 3 cans of cola, when they group together, they can still arrange among themselves, and it has 3 factorial ways as well. And by multiplication rule, the total ways we have, multiply them together. All right. But don't forget, 2 cans of orange are identical. So to get rid of the repeated ways, divide 2 factorial. As well as the 3 cans of cola, they are identical as well. Divide out 3 factorial ways. Okay. Now, to consider the green tea, as the question wants it to be not next to each other, we will try to consider this. I put the arrow in between these letters, the spaces in between these letters, and you can see that I have 4 red arrows here. That means there are 4 different places that I can simply select two of them and arrange the two green tea on them. Right? So the number of ways is given by 4p2. And don't forget, the two green tea are identical as well. So we still have to divide 2 factorial ways to get rid of the repeated ways caused by these identical letters. And by multiplication rule, the total ways for these restrictions, we multiply them. Hence, we are getting the number of different arrangements. So I would just write down number of ways. For this particular question, part 2. And use the calculator, calculate the value will be equals to 18. All right. And as you can see, the 3 factorial way for the 3 cans of cola arranged among themselves, but they happen to be identical as well. So the number of ways for their arrangements will be cancelled off each other. All right, so the total answer is 18 for part 2. Okay, let's have a look of the next questions. So for question 2, the 11 letters of the word remembrance are arranged in a line. All right, so the keyword, they are being arranged. Now, part 1, find the number of different arrangements if there are no restrictions. So that means we are going to arrange n objects, right? So for the working of part 1, we will try to write down the letters like this. R, E, M, E, M, B, R, A, N, C, E. We try to list down the same letters in the row, in the column, so that easy for us to identify them. Then we are looking for the number of different arrangements with no restrictions. Means there are 11 letters, means it has 11 factorial ways for them to be arranged. But due to 2 are identical, we divide out 2 factorial ways. 3e identical, we divide out 3 factorial ways. And 2m identical, we divide out 2 factorial ways. All right, so this will give us the number of arrangements with no restrictions. And the number of ways will be 1663200. All right, so that is the part 1. Now we look at the part 2. Find the number of different arrangements, again the keyword, which start and finish with the letter M. All right, there are 11 letters, and first letter must be M, and the last letter has to be M as well. That means there are 9 letters in between. Okay, so the number of ways. As the M are in the first and the last, we have 9 letters to be arranged. So there are 9 factorial ways for them to be arranged. And at the same time, there are 2 are identical. We need to get rid of the ways, and the 3e identicals. So as the m's are not being arranged, so we do not have to consider them. Using calculator, we will get the number of ways to be 30240. All right, that will be the answer for part 2. Now let's look at the part 3. Find the number of different arrangements which do not have all 4 vowels next to each other. According to these restrictions, the question does not want these 4 vowels next to each other. What does it mean? If we have these 2 vowels next to each other and the double E next to each other, do we want this number of arrangements? Okay, read the question again. Different arrangements which do not have all 4 vowels next to each other. That means we want this number of ways that this arrangement of 2 vowels together and the other 2 vowels together, we want. If we have A, E, E together and 1 E is not, do we want this number of arrangement? Yes, because we do not want all 4 vowels next to each other, right? As long as not 4 vowels next to each other, we want those number of arrangements. So for this kind of questions, in order to find out the number of ways, we can answer it like this. First, we take the total number of ways with no restrictions. Then we minus off the number of ways that all 4 vowels next to each other. All right, by using this method, we are getting the number of different arrangements which do not have all 4 vowels next to each other. All right, now the total number of ways with no restrictions is the number of ways we found in part 1. All right, in part 1, so which is 1663200. Now we need to find out the number of ways where all 4 vowels next to each other. So I will write down the letters below. So we have double R, we have double M, we have B, N, and C. And then we have E, 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 A. All right. So as I'm looking for the number of ways that these 4 vowels are together next to each other, so I circle them together. Now we start counting. 1, 2, 3, 4, 5, 6, 7, 8. So effectively, there are 8 letters to be arranged. All right. And at the same time, the 4 vowels, they can arrange among themselves, which it has 4 factorial ways. And by multiplication rule, we multiply them together. But don't forget, 2 are identical. We need to get rid of the repeated ways, and 2m identical, as well as 3e identical. So these calculations will find out the number of ways of the 4 vowels are together, are next to each other. So hence, the number of ways with no restrictions minus the number of ways where all 4 vowels are next to each other. Using calculator, the values will be 40320. The answer will be 1622880. All right. So this is the number of arrangement for part 3. Let's look at the next questions. So this is the questions that's similar to what we have discussed before. Please try this and put your answer in the comment below. Okay, so that's all for this lesson. This lesson is to discuss the permutations of R objects from N distinct objects with restrictions. We will see in next lessons. Bye-bye.
That's all for today's video. If you're interested in more genuine sharing by other geniuses, please subscribe to our channel and don't forget to turn on the notification bell, ding dong. Also, if you're struggling with 1 or 2 past year questions and the mark scheme just doesn't seem to help, Genie has got you covered. Feel free to let us know what question it is by filling in the Google form linked in the description below. GenieUs Hub will get genius teachers to fulfill your request for the solution. Genie will see you next time. Bye-bye.